Hello everybody. I'm going to be giving you a quick walkthrough of the programming manual for the ATV31, which is a VFD that we're going to be talking about for drives in year 3. Now, one thing to consider is that all the manufacturers, they do have slightly different parameter names. They have different interfacing methods. So some of them, like the one that we've got here, has a little dial and a few push buttons. Others have a full screen with more push buttons. Some have touch screens. So really it depends on how much your employer or the client is willing to pay. But the terminology for all these parameters that we're going to be talking about are very much the same manufacturer to manufacturer. So don't focus so much specifically on the fact that this is a Schneider product. Uh, Learn the terminology. That's what I'd like you guys to do. So we are going to skip ahead to page 4. And this is where it talks a little bit about setting the drive up. So the very first thing, of course, that you're wanting to check is you got what you ordered. The voltages are the same. It's the right model number. We're going to want to install the drive and connect power into the drive, and then our power wire or cables going out from the drive to the motor. We're not going to turn it on yet, though. We're going to do a little bit more configuring. Before we set or run the drive at all, we need to enter all of that motor nameplate information. The place we do that is in one of the submenus called the DRC menu. It's called the motor control menu, and it's where we enter all of the nameplate information. In order for a drive to accurately control a motor, the drive needs to know the characteristics of the motor. Now, there are some other advanced methods that the drive will use to calculate motor characteristics and things. That parameter would be an auto tune, which we're not going to get into too much in this course. Beyond that, we need to configure our I/O, our inputs and our outputs. Those can be analog, they can be discrete, and that's what really sets our drive, tells our drive what to do based on what information it has and how we want that motor to behave. And then settings are just general settings. So all of that needs to be set before we go ahead and start running motors. And as many of you know, if you are going to turn a motor on for the very first time, some loads are um, unidirectional. They're only going to want to turn one way. So you need to be very careful to either use a phase rotation meter to determine what direction that motor is going to spin, or do a very small bump test, which is where we momentarily energize the motor and see which direction it's going to turn. Okay, next we have factory settings. Now, the drive has many parameters. This drive has hundreds of parameters, and they all have a default. And this is where we talk about some of those defaults. So for example, the normal stopping mode right here is set to ramp stop. Just making sure we're still recording here. It's set to ramp stop, which is where we control or ramp down the speed of that motor, ideally to a stop. If there's a fault, then the drive will do a freewheel stop, which is exactly what it sounds like. It's going to remove power to that motor, and that motor will just coast to a stop. Acceleration and deceleration times, factory set to 3 seconds, but of course we can change all of this. Switching frequency, something that we're going to talk about, is factory set to 4 kilohertz. So switching frequency and output frequency are two different things that we'll be discussing a little bit further. And this drive has the capability to have a switching frequency from 2000 hertz to 16,000 hertz. And what you'll learn, if you haven't already, is how that controls our pulse width modulation output and gives us a really nice looking current waveform, which will help the motor to run much more smoothly. So we have the defaults for our analog inputs and outputs. Just going to go a little bit smaller here. Now the drive is going to calculate a number of things for us. And one of those things is the drive thermal protection. That drive thermal protection, basically it's going to protect itself from getting too hot. If it gets too hot, it's going to shut down a few things, and down at the very bottom, it actually says that if it's warming up too much, it will decrease that switching frequency in order to protect itself. This calculation of its thermal state is based on the motor current and time in seconds, so how long current is persisting. Drive is also going to calculate the motor thermal protection. So this is essentially overload protection of the motor. This is based on the motor current, time as well, and the switching frequency is going to have something to do with this as well. Or not switching frequency, sorry, the output frequency will help determine when that drive is going to shut off power to the motor in order to protect the motor, because essentially the overloads have tripped. And we're going to skip to page 10. This is what the front of this drive looks like. You'll see it in person in a different video. And basically we have a few push buttons. So we have an up and a down arrow, run and stop, escape and enter. And then all of the navigating and selecting things within menus this is a turn dial. So it turns all the way around both directions. And we use that to determine which menu we're in, which parameter we want to change, that sort of thing. And let's go to page 12. So this is the general breakdown of the menus that the drive has. First of all, we have settings. These are general settings for the installation of that motor and that drive. Then we have the motor control menu. So this is motor nameplate information that must be entered. Must be. I/O is our input and output configuration. So what do we want our digital inputs to do? Should they run? Should they stop? Should they jog the motor? Do we want 2-wire control or 3-wire control? When do we want our outputs to come on? In the event of what fault do we want our outputs to come on? The control menu. So how do we want things to be controlled? Functions, faults. So faults are going to be, it's going to help with troubleshooting a little bit, but you can also tell the drive when to or what to do in the event of a certain fault. Or there are some faults that you can set a predetermined amount of time or a number of time a certain fault will occur before the drive will actually fault out. Communication. So this drive communicates with Modbus, Industrial Communication Protocol. Not that important right now, but that's how it communicates. So there's a few different things that we can adjust with that. And monitoring or supervisory. So this menu, you get to pick what shows up on the face of that drive when it's running. So the default is you're going to see the output frequency to the motor. You can change that to represent speed, the motor thermal state, the percentage of torque, the drive thermal state, the current, the incoming voltage, the outgoing voltage. So there's a few different options that the drive can display for you. Next, we're going to move down to page 14. And this is a table of parameters, and it should make sense that not all parameters are going to be compatible with one another. For example, this right here means that they are incompatible functions. So preset speeds are incompatible with using the plus and minus speed on the drive. And a preset speed is a predetermined speed that we want the drive to go at, and we don't want it to change. Plus and minus keys, well, they change the speed, so it should be obvious that those are incompatible with one another. However, preset speeds and jog operation, if you recall, jogging a motor is where we make the motor move, and as soon as we remove a signal or let go of a push button, then the motor stops. So it's not a start-stop 3-wire control. If those two things are both active, so if we're in a preset speed and we enable jog operation, this arrow means jog operation will then take priority control over that motor. That's how this table works.